Alright, the objective is for this video is to be able to multiply fractions including mixed numbers and improper fractions. I did write some steps out for you, and actually I made it kind of easy. I went ahead and wrote steps for multiplying and dividing all together. So for this video we'll just focus on the multiplying fractions, in which case you won't need to do step 1b. You can see that step 1b is only for dividing. But as you probably already know, when we divide fractions, usually we end up taking the reciprocal of the second fraction and then multiplying anyway. So I went ahead and included that together. But again, if you're writing steps only for multiplying, then you don't need to include step 1b. Okay, should have been able to pause that, and I'm going to take it away now, and we'll do some practice. Okay, now there are a few tricks that I wanted to show you, and I'll explain them through one time, and then you can go back and watch it again. But the other examples that I'll do, I'll just kind of assume that you got the explanation the first time we showed those tricks. So let's start out with a simple problem of 3/8 times 1/4. Okay, so there are no improper fractions here, or mixed numbers here, so we don't need to convert them into improper fractions. It's already multiplication, so we don't need to do step 1b, I suppose. Now, step 2 says to see if any of the numerators share any factors with the denominators. Well, up here we have 3 times 1 are the factors, and 1 times 1 is the factors there. And then this, you could either do 4 times 2, or even further would be 2 times 2 times 2, and for the 8, and then 2 times 2 for the 4. And while they share factors with each other, they don't share any factors with the top. The denominators don't share any factors with the numerator, so we can't really do that step either in this case. So now I want you to be careful when we start doing multiplication and division. We can just go ahead and multiply straight across the top and straight across the bottom. That is not the case for addition. Remember, addition and subtraction, you need to have convert these fractions into equivalent fractions that have the same denominator. Okay, so if we were going to add these two, then we would have to change this to 2/8, but we're not. We're multiplying, so we don't need to change it. Just make sure that you don't try to, change all these around, or when you need to get the denominators the same in an addition and subtraction, you forget to do that. There are different rules for addition and subtraction, and then for multiplication and division. So we're going to go ahead and multiply straight across. 3 times 1 is 3. 8 times 4 is 32, and then I do believe that there's nothing that we can do to simplify that, and we don't need to convert it back because it's already a normal fraction. And then we can check by estimating. 3/8, well, that's a pretty small number, and we're going to make that even smaller by multiplying it times a number less than 1. So we should end up, if we start with a number less than 1, we multiply it by a number less than 1, we should end up with an even smaller number of 3/32. That's about 1/10 you could, estimate. So that's a pretty small number, so we're probably on the right track. It's not an exact science estimation, but I think that would be okay. Okay, let's try another one. Let's say we have 3/5 times 6 2/3. Okay, well, here we do have a mixed number. We'll need to convert that to an improper fraction. So 6 times 3 is 18. 18 plus 2 is 20. And over here we have 5 or 3/5. Okay, so, not equals, multiply, sorry. Now, the next step, step 2, says to see if any of the numerators share factors with the denominators. Well, sure enough, we see that this is 3 times 1 and this is 3 times 1. And also we notice that this is 5 times 1 and this is 5 times 2 times 2 or 5 times 4. So I'm going to go ahead and write these as their factors, and I'm going to write 3, that's this 3, times, and then I'm going to write 2 times 2 times 5 in place of the 20. Then on the bottom here I'm going to write 5 times 3. Now, we know that the commutative property of multiplication says that we can, if the operations are all multiplication, we can rearrange this order and we should get the same answer. In other words, 3 times 2 is the same as 2 times 3. So I'm going to put the ones that are the same on top of each other, and I'm just going to move this 3 over to here and write 3, and then I'll move the 5 over here. 3 times 5 times 2 times 2. And then on the bottom I'm going to write 3 times 5, and then there's nothing. You can say times 1 if you'd like. Now we can see 3 over 3, well, 3/3 is 1. So really we can just cancel those out. And 5 over 5 is also 1. So we can end up canceling that out. And then we're left on the top with 4. And then of course on the bottom we have this 1 that we assume is there. 3. So we're left with the answer of 4. Now, let's go back for a second and pretend that you didn't see that early on, and you went ahead and you didn't notice anything that canceled. You did 3 times 20, you would get 60. And 5 times 3, you would get 15. Now at this point you may notice that 60 divided by 15 is 4, in which case you would get the same answer. Or maybe you didn't notice that. Maybe you noticed that at least it ends in a 0 and it ends in a 5, so you could divide the top and the bottom by 5, and 60 divided by 5 is 12, and 15 divided by 5 is 3. And at this point you realize, oh wait, 12 and 3 can also both be divided by 3. And so you still get 4 over 1, which is 4. So either way you cut it, you can arrive at the same answer. But if you do this factoring first, and then you cancel the factors that cancel with each other, then you'll be able to see, or you won't need to simplify later on. You'll already end up with a simplified answer. Last but not least, let's just go ahead and estimate this. Let's see, 3/5, well that's a little over half, but not much, times 6, 3/5 times 6, and it's really almost 7 because it's 6 2/3, so 3/5, a little more than half, times 6 or 7, we should end up with something around 3.5 to 4, and sure enough we do end up with the answer of 4. So this is probably a good answer here. It's close to our estimate. Okay, let's do a couple more if we have time. Hopefully this is helpful. Well, let's do one more for the sake of time. Let's do 7 1/2. 7 1/12 times 5 19 over 25. Look at that problem there. Looks pretty intimidating maybe. We'll change these first to improper fractions. So I do believe that 7 times 12 is 84, and 84 plus 1 is 85. Put that over 12. Now, 5 times 25 should be 125, and if my math is correct, 125 plus 19 is 144 over 25. Now, most of you will recognize 144 as being 12 squared. So let's factor 85 factors into, let's see, I think it's 5 times 17. And, well, let me just show you. We could do 2 times 2 times 3. if you'd like, or if we can tell right away, this 12 is going to match up nicely with 12 times 12, we could just leave it. Okay, if you didn't do that, you would get 2 times 2 times 3, and on the top you would get 2 times 2 times 2 times 2 times 3 times 3. And then on the bottom we have 5 times 5. So instead of rearranging everything, I'm just going to show you how we can do this even quicker. We will cancel the 2 12s. We will cancel the 2 5s. You know, 1 5 on the top, 1 5 on the bottom, 1 12 on the bottom, 1 12 on the top. And we get 17 times 12. I already did that. It's 204. And we're left with only a 5 down here. And so 204 divided by 5 should be 40 and 4/5. Now, let's just check by estimating just to make sure. Let's see, we have 7, pretty close to a solid 7. 7 and 1/12 is just about 7, maybe a little bit more. And this is close to 5, just a little under 6, right? Just a little under 6. So a little over 7 times a little under 6, that's going to give you about 42 or so. And given, you know, that we rounded somewhat, 40 and 4/5 sounds like a reasonable answer. All right, that's it for this video. Thank you for watching.